time we have left. Are there extras somewhere? Right there. Who needs them still?
There's one right there.
Is this some of yours? No.
Good morning.
So what messed us up is some people didn't turn in a Scantron. That's why the passing out thing didn't work, because some people didn't turn one in, about 5 of you or something. So please bring a Scantron. I mean, you're big people. You can do whatever you want. But this is an opportunity to find out where you're really at. Why not take advantage of that opportunity, right? So bring a Scantron, fill it out on practice. You're just not trying real hard if you don't bring a practice exam today and work through that. If you don't bring a Scantron and bubble that in. So let's take a look. So practice exam number 1. Here we go. Part 1, cosecant of pi over 13. Write a cofunction. It says write a cofunction. Now, what does that mean, cofunction? How do we do that? Remember cofunction? 90 degrees. Co means complementary. Complementary angles make total 90 degrees, or what's 90 degrees in radians? Pi over 2. Pi is 180, so pi over 2 is 90. Pi over 2 radians. So that means you take that angle. What's the cofunction of cosecant? Secant. You take off the co. So remember, a cofunction is adding or removing the co. So the cofunction of sine is cosine. The cofunction of cosine is sine. Right? That makes sense? The cofunction of tangent is cotangent, etc. So the cofunction means adding or removing the co. We had a homework on this, remember? All these are homework problems. So the cofunction of cosecant would be secant. How do you find the angle? You take pi over 2 minus pi over 13. Why? Because that's 90 degrees. Remember, cofunctions total 90 degrees? Remember how we had this in the homework? Like if you had 20 degrees, the complementary angle would be 70. If you had 30 degrees, the complementary angle would be 60. If you had 50 degrees, the complementary angle would be 40. Notice they add to be 90. Complementary angles. Remember how we went over these in the homework? So what does that have to do with the pi thing? Well, if you have 20, how do you get 70? You subtract from 90, huh? 90 minus 20 equals 70. Or 90 minus 30 equals 60. Or 90 minus 50 equals 40. So you see, you get a complementary angle by subtracting from 90, don't you? So therefore, this is 90. Pi over 2 is 90. So I'm subtracting the angle they gave me from 90. And changing from cosecant to secant. That's what we did in that homework with cofunctions. All right. So it's going to be secant of pi over 2 minus pi over 13. How do you do pi over 2 minus pi over 13? Got to get a common denominator, right? So what are you going to do? Multiply top and bottom of this one by 13 and the other one by 2, huh? And so we get secant of 13 pi over 26 minus 2 pi over 26, which is secant of 11 pi over 26, which is option C on number 1. Question? What's that? Because that's the cofunction. So in other words, so what a cofunction means is add or remove the co. Add or remove the co. So if you're starting with a function that already has the co, take it off. If you're starting with a function that doesn't, put it on. Switch the co option. So if you're starting with cosecant, cut that off, and what do you have? Secant. Does that make sense? The problem started with this. This means cosecant, right? CSC. That's the abbreviation for cosecant. So when they ask for the cofunction, they mean if you got a co, remove it. If you don't have a co, put it on. So I removed it. All right. Other questions on that? That makes sense. It was option C. Well, you got all the answers. I don't need to write them. It put the right answers in there for the ones you missed, right? So you got all the right answers now. So I'll just crank them out real quick. Number 2, cotan of pi over 3. So without a calculator, how do we do that? Well, you get your 3x5 card, right? Make sure you have that for next Wednesday. 3x5 card. The real exam will be almost the same as this. It'll be same number of problems, 9 on the first part, 17 on the, so it is 17, whatever it was. Total 25, First part, no calculator, second part, calculator. exactly the same thing, except it'll be yellow and blue. Well, half of you'll yellow, half of you'll be blue. But otherwise, it's pretty much the same thing. Different numbers. There'll be one of these co-functions, for example. Absolutely, it'll just be different numbers, different function. But be just like this, which is what? Just like the homework. This is exactly what was in the homework, right? We had one of them co-function problems in the homework. So that's all I'm doing. Nothing amazing here. So cosine over sine, you can have that on your 3x5 card. So how do you do that without a calculator? Well, pi, remember, is 180, isn't it? So let me stick in a 180 here. So this is 180 degrees, 180 degrees over 3. So that's cosine of 60 degrees over sine of 60 degrees. So far, so good? Now, how do you find the cosine of 60 and the sine of 60? Yeah. What's that? Right. So let's go ahead and make a 30. So yeah, there's different ways. I usually show in the unit circle, but you want to show the little triangles. Whatever works for you is fine with me. So let me make, 60-degree angle. Where's the 60? It's right there, huh? Remember, the 30's here, 45's in the middle, 60's here, almost to 90, right? So 60's there. Now, what does that mean? So what, the 60's there? Well, that means you go over a little bit, up a lot to get to the 60-degree angle. Remember the small, medium, large, like ordering a soda? Root 1, root 2, root 3, all over 2. Remember that? Those are the ones you can put on your 3x5 card or just memorize really easily. And you just find the 60-degree angle, and you can tell 60-degree angle, that's over a small amount, that which is the same as a half, right? The root 1, you don't need the root. Root of 1 is just 1. And up the large amount. Over just a little bit, up a lot, huh? Over the small, up the large. Okay, so what? Well, then what's cosine? X. Cosine is always x, remember? So that's a half. What is sine? It's always y. Root 3 over 2. Let me bring that down here. What do? With a fraction on the bottom, you bring this guy up. The high diver does a flip upside down. 2 over root 3 like that. Cancels the 2. 1 over root 3. But we can never leave roots on the bottom. So we multiply top and bottom by root 3. So you get root 3. What's root 3? Root 3 on the bottom? Plane 3. There we go. So that's answer D, huh? Root 3 over 3. Good on that one? Questions I can answer? How we doing? All right, I want to keep moving. I want to get through as many as I can. This will be on the YouTube, so you can watch it later. So I know I'm probably whipping ahead of where you're at, but it'll be on the YouTube. I just want to do as much as I can for you in the time we have. Tan pi over 6 minus sine pi over 3. Again, this is the no calculator part, so let's put that in. That's 180 over 6, 180 over 3. So that's tan of 30 minus sine of what, 60? So again, 30, 60, 90. Let's do the little unit circle. I'll go to it and say, okay, I'm looking at 30 degrees and 60 degrees. Tangent, what's that? Sine over cosine. You put that in your 3x5 card. And then sine 60 here. Okay, now, so we're talking about 30. Let's do the 30 first. Here's the 30-degree angle. What's that? That's over a lot. That's over, remember the small, medium, large. Small, medium, large is a half, root 2 over 2, root 3 over 2, right? So it's over a lot, over a large amount, up a small amount, up a half. So the sine of 30 is the what? The y coordinate, always the y. Remember, sines are y, cosines are x. So that's a half over, what's cosine of 30? That's the x, root 3 over 2, minus, now what's the sine of 60? How do I do 60? Well, for 60, maybe I'll draw another unit circle down here. For 60, got to go up here, 60 degrees. Over a small amount, up a large, huh? For 60, over a half, up root 3 over 2. Which one's the sine? X or y? It's the y. There's the sine. Sine is always y, cosine is always x, huh? By definition. So root 3 over 2. So those are the two things we need to subtract. So far, so good. Now, how do we do that? Well, this guy flips up, does his high dive upside down, times 2 over root 3. These cancel. Minus root 3 over 2. So that's going to be 1 over root 3 minus root 3 over 2. That's just ugly. So let me come up here. I'm kind of running out of room and everything else on this problem. So let me kind of come up here. So I've got to multiply top and bottom by root 3. root 3, root 3. So that makes it, what? That makes it root 3 over plane 3 minus root 3 over 2. We okay so far? Right? See what happened here? Right here. That made it root 3 over plane 3 minus root 3 over 2. So now common denominator, multiply, because you put those fractions together, which requires common denominator, multiply top and bottom by 2, top and bottom by 3 to make both denominators 6. 2 root 3 minus 3 root 3 over 6. Right? 2 roots of 3 minus 3 roots of 3 over 6, which is what? Negative 1 root 3 over 6, right? Negative, is that on there? Is that a none of the above? That's dastardly, huh? After all that work. There are a couple of none of the aboves. What was there? 1 on the first part and 2 on the second or something? Something like that. You know, there'll be a few. So that's a none of the above. After it's a little disturbing, huh? You do all that work and you're like, uh-oh. But no, some of them are. As long as you're confident in your work, you'll be fine. There are some none of the aboves. Is that good? Is that okay? A lot of work, huh? Math takes practice, doesn't it? You got to put hours of your life in. Hours of your life. It will not come to the casual. So if you want to pass, this is what it takes. I'm glad to help you. Come see me. I'm upstairs today, 12 to 1. Be glad to help. Roberto's available. All right, let's keep moving. Number 4, secant. Secant, a minus 3 pi over 4. Stick in the 180. There's 3 times 180 over 4, like that. And also secant is 1 over cosine, isn't it? I always just turn it into sines and cosines. If you notice, I just turn everything into sines and cosines. Right? Whatever they give me, you can make all of them into sines and cosines. Even tangent is just sine over cosine, right? I just always turn everything into sines and cosines. Have you noticed that? And then I go to the unit circle and do the small, medium, large. And the sine is the y, the cosine is the x. And I get all my answers. That's what I've been doing in the homework. It's what I'm doing now. Is that making sense? Just turn everything into sines and cosines. So you have on your 3x5 card the definitions. Secant is 1 over cosine. So what is this? Well, use your calculator. Well, you can't use your calculator on this part. 4 goes into 180 45 times. If you're not sure, go over and do it on the side. 4 goes in that. 4 times 16, 25. 45, so that's 45. And then 3 times 45, 15, 12, 13, 135. It's minus, because of the negative here. So it's minus 135 degrees. So I got to do the cosine of minus 135 degrees. Now, what have we learned about cosines with negatives and positives, I mean? What can we do? Oh, yeah, that's a different thing. I mean, like when you have a negative in there. What does it do? Remember, we learned 2 special rules. Some functions, the negatives can kick to the front. Some of them, they can vanish. Which one's cosine? Vanish. Just ignore it. Completely ignore it. You can totally ignore that sign if you want. Now, you don't have to memorize it if you're thinking, it's too many rules. I'm with you. I don't like having a lot of things to remember. You could just say, whatever, I'm just going to do a minus 135. That's fine, too. I'll just do minus 135. Where's that? Well, you just go down. This is negative 90, and then 45 more, right? Because 135 is 90 and 45, isn't it? So that's going to be with the unit circle. It's going to be halfway right there, isn't it? So this would be minus 135 all the way to there. Everybody with me? I'm not drawing that very clearly. This is minus 135 right there. Does that make sense? You can just do that. Forget about that negative stuff. I mean, if you remember that, great. You technically can just ignore that negative. We learned cosine's an even function. But, I mean, maybe you don't have that memorized. All right, whatever. So just find out minus 135. So there it is. Okay, so what? Well, that means that, make a little triangle there, over, down. Now, that one's right in the middle, huh? So that's going to be medium. Remember the ones right in the middle? As opposed to you got 30 here and 45 in the middle, 60 here. So the ones in the middle, those are, remember the small, medium, large. Whoops, it's an L. Small, medium, large. A half, root 2 over 2, root 3 over 2. So they're going to do the middle with middle, medium with medium, right? Medium always goes with medium, and small and large go together. So this is back, root 2 over 2, down, root 2 over 2. If you're not, I'm just going back and down, so they're both negative. But yeah, you can just do the all students take calculus if you don't want to worry about the signs. So anyway, what's cosine? X or Y? X, doesn't matter, they're the same, huh? So cosine is x, so it's 1 over negative root 2 over 2. We good? 1 over cosine. Cosine is negative root 2 over 2. Like that. That's the x value there. And it is negative because remember the all students take calculus. Only tangent is positive in this quadrant and his upside down cotan. The other 4 trig functions are negative. No surprise, cosine is negative. Flip this guy up. He comes up and he flips. 1 times 2 over root 2 negative. And then that's negative 2 over root 2. What do we do with that? We can't leave the root in the bottom. Multiplied by a root 2, top and bottom. Negative 2 root 2 over plane 2, right? Root 2 is plane 2 in the bottom. Cancels it out. Minus root 2. After all that work, that's a lot of work, huh? Minus root 2. Is that good? We okay? Questions on that one? All right, on we go. Onward and upward. Number 5. Cotan minus 8 pi over 3. Okay, boy, these are taking, I want to get through some of the other stuff too. All right. Put in a 180 like always. So that'd be cotan of minus 8 times 180 over 3. You know the drill. 3 goes into 180 60 times, and then 8 times 60 is 480. So this is not cosine, cotan of minus 480. Good to there so far? Now, what do you do with like a negative angle? I would just start adding 360s. You know what I mean? Just add 3, because 360 was up minus 120. Add another 360. 240. Not good? Just keep adding until you get something nice and positive. I could have done that back over here too. I could have just added 360 to that. That's okay. You can always add a full circle. You're in the same spot, huh? When you add a full circle, you're in the same spot. So you can always do that, and then you get a nice positive angle. So this becomes cotan of 240. We good so far? And cotan is what? Cosine over sine. So see how I always break it into sines and cosines. And then how do I find those? The unit circle, right? With small, medium, large. Right? Y'all getting the gist? It's always the same thing, huh? So I just go to the unit circle now, and I go, okay. Where's 240 degrees? This is 90, 180, 270. So it's 30 away from the 270. It's close to the 270, huh? There's 240 right there. So what is that? Back just a little bit, down a lot. See, right? Because here's this one, here's this one. It's the one closer. So it's only back a little bit, down a lot. See how I'm always using the small, medium, large unit circle to find sines and cosines? That's how you want to do these. So let me get some room here. And so what are those? And you know the small, medium, large, right? Small, medium, large. A half, root 2 over 2, root 3 over 2. So it's back a small amount, down a large amount, isn't it? To get to here, right? It's only back a little bit, down a lot, right? This 240 is almost to 270. Okay, so what's the cosine? The x. So this equals the cosine on the top, minus a half, over the sine on the bottom, which is the y, minus root 3 over 2. You know what to do. Flip it up. Minus a half times minus 2 over root 3. 2's cancel. 2 negatives make positive. 1 over root 3. We can't leave a root on the bottom, so we multiply top and bottom by root 3. Get root 3 over plane 3. 2 roots on the bottom make a plane 3. Now, double check the sign. It's always good, multiple choice test. You want to make sure you got the sign right. All students take calculus. We're in the third quadrant. Only tangent is positive. So, and his upside down cotan. So cotan should be positive. Yep, answer came out positive. That's right. Did we get that one? That was B. I guess it was B on the multiple choice. Questions on that? Is that good? Are we happy? Are we shocked? All right, this is just homework, right? Right? I mean, this shouldn't be shocking. Was the homework. I'm not going out of bounds here, am I? This is exactly what was in the homework. We did ones exactly like this in the homework, right? This is, but you really have to learn these things. Cosecant 5 pi over 3. So unit circle, cosecant 5 pi over 3. Boy, if I keep, all right, I keep wanting to quit these because these taking forever. And they seem like the same thing over and over, yeah. 180, put in a 180. Yeah, they do. They really do. But maybe that's helpful. You guys getting the hang of these? See how these are just kind of the same every time? Just put in the 180, get the angle, break it into sines and cosines, unit circle, small, medium, large. Cosine is x, sine is y. Right? If you get that whole process down, you can crank out a bunch of these. If you don't, you're going to miss a whole bunch of these, right? So you really want to get that process down. So 3 goes into 180 60 times. 5 times 60 is 300. So that's the cosecant of 300 degrees. 300. No, cosecant, what is that? I'm going to break it into sines and cosines. What's cosecant? Roberto, what's cosecant? Look at, he just knows it, right? He didn't even hesitate. So I just want to point him out because we're all there. I think there's some shock in the room right now as we're going over the practice exam. There's a man that will help you. Me too. I'm glad. Come to my office hours 12 to 1. Let me say this. I was constantly in my teacher's office hours. Constantly. So let me break any ideas that means you're stupid. Right? That just means you're trying hard. That's what that means, right? I was constantly confused in the homework. And I'd make notes. Every time I didn't understand homework, I'd make a note because I cared a lot. I didn't want to make Arby's roast beef sandwiches all my life. I thought, I am going to make this happen. Junior college, I'm going to be successful. No more high school fooling around. I'm going to get it together and get a life, right? So every time I didn't understand a homework problem, I would write it down. I had a list. And I think my teachers were afraid to see me coming in the halls. I go, oh, there's that Heron kid again. Get out of here, kid. You bug me. No, I'd see him and I go, Mr. Jones, Mr. What, Mrs. Whatever. How do you do number one? How do you do what's going on? Why did they move And they would explain it to me, and my misunderstandings would solidify into understanding. But that was hours of my life. I didn't just come to class and scoot out and not do homework and do a half job on it. And no, you won't make it to university or get a bachelor's degree in anything math science that way. It will not happen. Don't fool yourself. Be all in or be all out. The worst thing to do would be to be half in, right? Because you're just wasting your time. You're going to fail. If you're half in a math class, you're going to fail. So go get a job or something for these hours. Make some money. Don't waste your time 4 hours a week sitting in here. Don't be half in. It'll get you nowhere. If you're not all in, go do something else. Wouldn't that be wise? Wouldn't that be smart? The most unsmart, that's not a word, huh? The worst plan, the least wise plan would be to be half in, right? But I find so many people do that. And I'm like, guys, gals, don't be half in. That's the worst thing. Be all in, ace this thing, get a good job you enjoy, or go get that job now. Why waste hours of your life and money and stuff being half in, right? So the help is here. Roberto's here. I'm here. Tutoring center's open even when Roberto's not there. Get the help you need, but you got to master these problems. 1 over sine 300. All right, you know the drill. Unit circle. Here we go. Where's 300 degrees? Well, here's 270, so it's just off of that one, right? 300. So you guys getting the hang of, am I doing okay with, is it making sense where I find them and then the small, medium, large thing? So that means from here, I go over just a little bit, down a lot, huh? Can you see that okay? So that makes sense. So it's over a small amount, down a large, right? And see how it's over, it's positive, and it's down, positive. You don't have to do that. Don't worry about it. If the signs bug you, don't worry. That's how my daughters were. They were like, Dad, we don't care about the signs. We're just going to do the all students take calculus. Great. That'll work fine. Just forget about the pluses and minuses and figure out the sign at the end with the all students take calculus. That'll be fine. So the small, medium, large thing, So small, medium, large, a half, root 2 over 2, root 3 over 2, right? So this is over a small amount, down a large. Well, I'm always doing the signs, but you don't have to. It's over the small, down the large. What's the sign, X or Y? It's the Y. There it is. So it's 1 over minus root 3 over 2, like that. We good? And then you know the drill. Give her a flip. Flip this guy up there. 1 times 2 over root 3. So that's minus 2 over root 3. What do you do with that root? Multiply top and bottom. We've done this a couple of times, haven't we? So, and then what is that? Minus 2 root 3 over plane 3. Hopefully that's on there. Is that on there? D. It's like option D. And it is negative, right? Because only cosine is positive, and his reciprocal in that quadrant. So, yeah, cosecant is going to be negative. Good? It's all making sense? They're kind of the same thing every time, aren't they? This whole process? Number 7. I want to get on. Boy, I'm getting nervous, so I'm not going to get on those other ones. Could I just skip 7, 8, and 9? They're the same thing. I'm going to go 7, 8, 9, same. You have the answers? I'm going to go on to part 2. I want to do some more part 2, which is different. Let's go on to part 2. So now part 2. Question number 1. Now you can use your calculator. This is the calculator part. Negative 7 pi over 6. So I'm requiring the non-calculator in that part 1 because I want you to know that unit circle thing. I want you to see those angles. I'm not trying to torture you. I'm really not. But I'm trying to help you with calculus. Calculus, you're going to do limits, and you need to have a feel, because they're on the move. You can't just have them memorized those. You've got to have a feel for what's happening with that unit circle for limits in calculus. So, all right, you can do this stuff. Negative 7 pi over 6. So they give me like pictures, and they want me to say, where is that thing? What does that look like? Well, I would just put in a 180. So this is negative 7 times 180 over 6. And 6 goes into 180 30 times. Negative 210 degrees. So where's negative 210? Well, here's negative 180, right? So negative 210 is just a little further than that, just 30 more. So negative, 210. Yeah, so that, if you look at the pictures, it looks like D. Yeah, just a little past the 180 line. Is that good? On that one, that's probably a little easier. That's a breath of fresh air after all that other ones, huh? Number 2. If I can try to squeeze in here. Find the radian measure. R equals 1.5. S equals 2.25. And it says blah, 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 blah. Find the radian measure of the central angle. All right. What formula do we have? You put it on your 3x5 card involving S and R. S equals R theta. Remember that formula? Put it on your 3x5 card. S equals R. S stands for arc length. So have S equals R theta definitely on your 3x5 card. That's one of the ones we did in homework. All right, and it says S is 2.25, so this is 2.25 is R 1.5 times theta. Good so far. Just put in the S, put in the R. How do you solve that for theta? Just divide by the 1.5. You can use calculators now. So please tell me, is it 15? What is that? I didn't bring my calculator. Oh, just 1.5? Thank you. So theta is also 1.5. And is that answer not there? Is it E? It's an E, which can be disturbing. Let's see. There's a couple E's. Questions on that? We good? These are a little better, huh? These aren't quite as bad as that part 1. So I'm going to move on, if that's okay. Get as many of these done as I can. Number 3. I'll be on YouTube later. Convert. So minus 54 wants me to convert to radians. That shouldn't be too bad. So multiply. Now, when you convert the radians, it's the pi 180 thing, right? The only thing is to know which way to go. How do you know which way to go? You want radians, you want the degrees to cancel. This is over 1. So you got to put degrees down below. Does that make sense? You want degrees to cancel? So you put it down below. So what do we got? Minus 54 pi over 180. Some of your guys' calculators will reduce fractions automatically. The Casio Natural Display, just type in 54 over 180. Some of the other calculators as well. Hit enter, it'll just reduce it for you automatically. You guys know how to do that? Save some time, right? Use the fraction button. Do you guys know the fraction buttons on your calculator? guys know where that's at? Use the fraction setting. Grab me after class if you're not sure what I'm talking about. A lot of calculators. Can I see your calculator real quick? I want to show you. The other one's easy, but this one, probably fraction buttons. One of those two. Yeah. Wait. Yeah, there it is. Yeah. Let me show on this one real quick. You know, so this is the Casio natural display. It's real obvious. Maybe I'll show that one too. But where am I at? There we go. So look at this. Let me show you. Save some time on all these fraction things real quick. Come on, baby. Hello. There we go. All right. So here's a little TI. I want to show you. See right here. See this. What? Oh, this button here on the TI anyway. This A looks like a mixed number kind of thing. Make it even bigger. See that? Okay. That's a fraction button. Is what that is. So notice if I wanted to do, what is it, 54 over 180? That's what we just had on the screen. Watch. Instead of dividing, I'll just go 54. Then I'll hit the fraction button. I'll hit 54 fraction. That's how it shows it. That Casio's even nicer. But 54, boom, 180. Don't worry about the negative. We know it's negative. So that's 54 over 180 as a fraction. That's how the TI writes it. So I hit the fraction button there in the middle. Okay, 54 fraction. Wait, now watch. Just hit equals, boom, 3/10. Just reduces it for you automatically. If you need to change to decimal or between mixed numbers and fractions, you can hit that right there. Between fractions and decimals right there, which means hit second. Now watch, I'll change to decimal. You know what 3/10 is, 0.3, right? I'll hit second FD. And then it says, you want to go there? And I go, yeah, hit enter. 0.3. Now I'm going to go back now. Second, go back to the other one. Hit enter. Okay. See that? So that's on the TI. Use the fraction button. Just reduce them for you automatically like that. Thank you. Can I use one of the H? That one looks. Somebody have a Casio. Yours might be the same. I don't know. Might be a little different. Oh yeah, this one's what I'm used to. Yeah, this one's probably. You probably don't need me to show you this one. This is real obvious. This is the Casio natural display. It's real obvious. It's got this fraction button right here. So if I want to do a fraction, let me just clear everything. Hit that, boom. It's clearly a fraction. This is why this one's so nice. It's natural. Like they say. 54 down 180. Right? Yeah. And just make a fraction. Just hit enter. 3/10. It just automatically made it that. Yeah, on that one, if you have this one, this SD button right here, this converts it between all kinds of different forms. I don't know why that doesn't light it very well. Does that help? Yeah. All right, so 3/10. Hit this SD button. It'll change this between decimal, fraction, all that kind of stuff. Hit SD. Boom. See 0.3? Hit it again. 3/10, 0.3, 3/10. It goes back and forth, whatever you need. The SD button. Casio Natural Display, that's why I could be a salesman for it. It's very nice. It is. They did a good job. Same price as all the others. That's why I'm like, we have 3 of them. So they're nice. $10, $12. Walmart, Target, might be 15. Bookstore. So anyway, the other ones, the TIs will do it too. They're just not quite as user-friendly. All right, anyway, just wanted to show you that. So you can use that on the calculator part. Part 2, which is most of the test, you can just hit 54 180, hit the button, and it'll do it for you. You save some time. Minus 3/10 pi, and we got the answer. It's D. Let's go on to number 4. So positive angle minus 13 pi over 9. 13 pi over 9. What do we do for that? What does it want me to do? Find a positive angle less than 360 or 2 pi that is coterminal. Basically, they want you to turn that into a positive angle. Now, remember, at any time we want, we can add 360, right? You guys with me? Because 360, wherever you're at on the unit circle, say you're here, if you add 360, you're at the same spot, huh? You haven't really moved. You've gone all the way around the circle and you're at the same spot you started at. So you can always add or subtract 360 degrees and you won't change really where you're at all. So, okay, what does that mean I'm going to do here? I'm going to add 360, but what's 360 in radians? 2 pi, right? Because pi is 180. So just add 2 pi. How many times? I don't know. Till the thing becomes positive. I really don't know. I'm just going to start adding 2 pi. But I got to do it with like a common denominator. These are 2 pi's over 1. I don't know how many I need. I'll just write a couple of them and we'll see. But I got to do it with a common denominator, don't I? So what do? I come in here and multiply top and bottom by 9 for each of these, right? To make it ninths, so I can add fractions there, right? So what do we got then? Minus 13 pi over 9 plus 18 pi over 9. That's a fancy 2 pi, isn't it? That's a 360, huh? So I'm not changing anything. I'm adding or subtracting, either way. 360, nothing changes. So how many of these do I need? Oh, it looks like we only need one. One of them will do it, huh? One of them will do it. 18 minus 13 is 5 pi over 9. Done. Is that okay? Does that make sense? Questions I can answer on that one? So this one was D. This one is, I don't know what. There's B? Yeah, looks like B. We good there? I'm going to go on to number 5. 5 says lawn sprinkler, angle 105, distance. So angle 105, distance equals 60 feet. What is the area of the lawn? Area of the lawn watered by the sprinkler. So what are they talking about? Like area? So if you got like a sprinkler head, do you get the idea? It's gonna do this kind of thing, right? The little sprinkler head is gonna go and sprinkle. It's gonna sprinkle a sector of a circle, isn't it? And what a sprinkler sweeps out, sector of a circle. It's gonna turn through an angle of 105 degrees. It's actually a lot more than I've got here, right? So if you have a circle, it's going to circle through 105, which is more than 90, so something like that, 105 degrees, and it's going to the sprinkler head right here is going to sweep out some area of lawn. It's going to water an area of lawn. Well, therefore, we need the area formula. Do you have that in your 3x5 card? You will for next Wednesday, right? Area of a sector of a circle, what is it? A half r squared theta. So put that in your 3x5 card. We have the S equals r theta. S is if you wanted just the length of the edge. A is you want the whole area of the whole thing. Half r squared theta. So that's the formula I'm going to use. So it's a half r squared. What's r? 60. That's the distance. The distance is 60 feet. That's the radius. That's how far the sprinkler shoots, 60 feet, the radius of the circle. That's the r. So r squared, 60 squared, theta. Now, we'd like to say theta is 105, but that's not right, huh? Why not? Has to be in radians. Remember that? So let me go to a new page if that's okay. So number 5, A equals a half r squared theta equals a half 60 squared theta. And the theta is 105 degrees, but it must convert to radians. Remember, for this formula, also S equals r theta formula requires radians. I didn't mention it. We did that problem a minute ago, but it already was in radians. I probably should have mentioned it then. But if they had given, I don't know what's on the, I don't even remember. But on the real exam, I might, vice versa, I might give you this one radians and the other one degrees, and you have to convert the other one. Anyway, just remember, both these formulas, you got to do radians. You got to do radians. So write that. So when you write this on your 3x5 card, write radians only. Rad only. Same thing with the S equals r theta. Rad only. So I got to convert the 105 to radians. So take 105 degrees, convert it. You get your calculator. 180 degrees down here, pi up here. Just put 105 over 180 on your calculator and hit the fraction button. Reduce it. Or you could divide by 5 to do it by hand. Divide by 5, it'd be, what's that, 21 something, 36? Oh, it reduces again, doesn't it? Then divide by 3. Did I do that right? 50, yeah, and then divide by 3, it's going to be 7/12 pi. So easier if you just use the button on your calculator to reduce it. 7/12 pi, so that's the theta in radians. So now let's put that in. Let's go back to the A formula. This was taking a lot of work. A half r squared, 60 squared times theta, which is now 7/12 pi. We converted that angle. We converted that angle of 105 degrees to 7 pi over 12. And now, just hit the buttons on your calculator now. Right, I would just make that 0.5 on my calculator. 0.5 times 60 squared times 7 divided by 12. guys all know what I'm talking about? On that, I would just go 0.5 times 60. I'd probably just go times 60 times 60. Times 7 divided by 12 times pi, hit the equals button. Right? Just anything on the top, when you have a fraction, anything on the top is multiplied, anything on the bottom is divided. And it doesn't matter what order. You could divide the 12 first, then multiply by the 7. Doesn't matter. Top stuff is multiplied, bottom stuff is divided, right, in a fraction. So just 0.5 times 60 times 60 times 7 divided by 12 times pi. Use the pi button, equals, and somebody got an answer there? What is it? 1050. 1050? 1050? Okay. 1050. Is that one of the answers?
Yeah.
Oh, 1050 pi. I see, 1050 pi. Yeah, so if you want to just do these numbers and then just leave the pi, don't do the pi button, that's fine, yeah. Right, there's two ways to go. And I gave both answers there. Right, you can just leave the pi as pi, just do these numbers, and it comes out 1050, and leave the pi there, 1050 pi, which is answer B. Is that okay on that? You good? 5 minutes? Oh my goodness. Okay. All right, let's do number 6. Car wheel, 16-inch radius. Through what angle does the wheel turn when the car rolls forward 5 feet? Okay, so if you got a car and it's rolling forward, the distance it rolls is the arc length spread out. You ever thought about that? This is how engineers calculate things with engines and torques at distance and tire size. This is what they actually do. So in other words, how far along, as the tire rolls, this arc length rolls out, doesn't it? That's what happens when vehicles roll. This is mechanical engineering here, right? So in other words, arc length formula is S equals R theta. S is arc length equals R theta, okay? So it has a 16-inch radius, so that means this is 16, the radius of the tire. Through what angle, what's the angle, does the wheel turn if it rolls forward 5 feet? So if the arc length is 5 feet, that's a 5, it looks like an S. And so the arc length is 5 feet, because it went 5 feet along the ground, right? This is S, which equals 5 feet. So it rolled out 5 feet. What angle theta must it have rolled through to roll out 5 feet? In other words, R is 16. 6? Yeah, 16. R is 16. And what's theta? They want me to find theta there. So S equals R theta. Solve for theta. How do I solve that for theta? Divide by 16. Theta equals, so 5/16. But that answer's not there. They've got a bunch of answers in degrees. So this is radians right now. I got to convert that to degrees. So take 5/16 radians times, and you got to put radians on the bottom, huh? Because you want radians to go away, and degrees on the top. Am I going too quick there? Everybody see what I'm doing there? I'm converting my radian angle answer. Remember, S equals R theta is always radians by default. But the final answer on the multiple choice is degrees. So I take my 5/16 and I convert it to degrees. How do you do that? You got to get rid of radians. Remember, you're always motivated by what you're trying to cancel. Go into degrees. So hit the buttons on your calculator, and which means what? Take 5 divided by 16 times 180 divided by pi, and use the pi button on this one. Somebody got an answer there? What's the answer on number 6? Or actually, it's, we do add 9. It's for number 15, right? Is that what it is, number 15? 6 on part 2. Yeah, it's C. So it's 214.9. Is that what that comes out to be? Is that right?
How come you don't have, one is in inches and one is in feet? Do you have to convert, or you just keep?
Oh, was there a mix of units?
Mm-hmm.
Oh, you're right. I didn't even notice that. Good eye. No, I'm messing it up. That's That's kind of dastardly. I didn't notice they did that. I don't. Yeah, that's tricky. So yeah, you gotta convert. You gotta get them in the same units. Oh, I blew that. Look at the time now. Thanks. I blew that. Yeah, let's go back. I don't like it when they mess with units like that. I mean, we got enough to worry about. All right, let me fix it real quick, and then we'll be done. I guess as far as we're gonna get. Yeah, you got to make them both inches or both feet. Doesn't matter. Just get them the same. So probably the easiest thing would do just to take 5 feet and multiply by 12, and that's 60 inches, you know. And the other one is 16, so the R is 16 inches. The S is 60 inches. And then it'll work. Does that make sense? I just converted them both to inches. 5 feet times 12 inches in a foot is 60 inches. And the radius is 16, it always was. And so, yeah, then you can divide by the 16. And you get 60 over 16. Then you got to take that and convert it. That's radians times 180 degrees over pi radians. So 60 divided by 16 times 180 divided by pi. Hit the buttons. Does that one come out to 14.9? Is that one coming out right? There it is. Thanks for that. I didn't notice their little trickery. All right, that's as far as we got. You got all the answers. I'd be glad to help you. Roberto would be glad to help you out. Monday's a holiday. I won't see you for a week.
Do you want these back?
No, they're for you.
Okay.
You keep it all. Study hard. I'll see you in a week.